Imagine asking your database, who are my top 5 paying customers this month? No SQL queries, no joins, just plain English. I built a text-to-SQL AI agent that makes this possible, and in this video, I'll show you exactly how it works and how to build it yourself. But wait, you're probably wondering, what even is a text-to-SQL AI agent? At a high level, it's a system that takes a plain English question, converts it into an SQL query, runs that against a database, and then returns the results back in natural language. By the way, if you're new here, I'm Fraser Dorado, and I've been building large-scale software systems for almost a decade, and now, through my AI and automation agency, I help build AI systems that give businesses an edge. In this video, I'll walk you through the exact code I used to build a text-SQL AI agent, step by step. And if you find this kind of content useful, make sure you subscribe so you don't miss future deep dives into building AI systems. All right, before we dive into the code, let's take a step back for a second. Because you might be wondering, why even build something like this? The thing is, no matter what business you've got, you're sitting on data. That could be customer records, sale numbers, operation logs, you name it. And most of this data lives in some form of database. That might be spreadsheets, an Airtable, or more often, a relational database like SQL. In fact, the vast majority of companies today rely on SQL databases as their primary way to store information. Now the problem, getting insights out of this data is slow. You either wait for an analyst to pull up reports, or you jump in yourself and start writing messy queries. And that's exactly the pain point a text-to-SQL AI agent solves. And that's why it's so valuable to businesses today. Don't forget, Uber built their own query GPT, which now leads to saving an estimated 140,000 hours per month in query writing efforts. That's massive impact if you think about it. Imagine the change this agent could drive in your company. Now that you get the why, let's jump into what we've got in store for today. Alright, so what exactly are we putting together? We are building a text-to-SQL AI agent with an architecture like this. A chat-style front-end for the user to interact, a back-end agent in Python that figures out what the user meant and turns it into a SQL query, a database, generally a SQL server, but for this demo, we'll be using SQLite that runs the queries, and finally, an AI model that explains the results back in plain English. You can ask questions like, who are our top 5 customers by total spend? It fetches the list of tables, gets the required schema, and then creates the query that it needs, right? And then it's able to deduct that these are the top 5 customers by total spend. Or maybe you want to ask, what's the average spend per customer? Again, it lists the tables, uses the required schema, and then creates the query to find you the average spend per customer. Notice how I didn't type a single SQL query, just plain English, and the system does the heavy lifting for you. All right, with that, let's take a quick look at the tools, libraries, and frameworks we'll be using today. For the front end, I use React with Next.js, plus a library called Assistant UI. Now, Assistant UI gives you a ready-made chat interface that feels a lot like ChatGPT, but a fair warning, if you try to customize it deeply, the docs can feel a little sparse. I may or may not have spent hours yelling at my screen, trying to get it to work. But for basic chat flows, it's pretty solid. Now, I've already set that part up for you because today's focus is really the backend logic. On the backend side, we're using FastAPI to handle requests, LangChain for its pre-built tools, LangGraph, which is a graph-based orchestrator that connects all the steps, SQLite running as a database, and finally, OpenAI's LLM to power the natural language understanding. Now that we've got the overview of the setup out of the way, the next part is super important, so pay close attention. Before we wire everything together, I want to break down the core logic of how this agent actually works. We'll walk through it step by step in a Jupyter notebook I've prepared, so you can see exactly what's happening under the hood. And then when we walk through the app, you'll understand how it all ties together. So let's dive in. To set things up, we're going to initialize our LLM using the init chat model from LangChain. We're going to use OpenAI GPT 4.1. Next, we're going to set up a database, which is a SQLite database. I put in a few print statements to see it actually being executed. So as you can see, the dialect is SQLite. These are all the available tables right now, and a simple select query to see that it actually works. Next, we're going to set up our SQL database toolkit. This is a toolkit that is provided within LangChain community. Right, you just pass in your DB and LLM, and you get a set of tools that are pre-built for you. What does these tools contain? So it contains an SQL DB query tool, an SQL DB schema tool, an SQL DB list table tool, and an SQL DB query checker tool. This is going to make a lot of sense when we integrate it into our agent. If you watched my last video where I explained that AI agents are basically a prompt and a loop, and how to use the React pattern to build one, this is going to make a lot of sense. We're going to use the pre-built create React agent from LangGraph, where we just create a system prompt, and the system prompt basically tells the AI that it's designed to interact with the SQL database. We pass in the dialect, the max number of results that it should return by default. We also specifically mention not to make any DML statements, so that's insert, update, delete, drop, etc. to the database. We create this agent by calling the create React agent, passing the LLM, the tools, and the system prompt. Then we ask the question, what genre on average has the longest tracks, right? And the agent.stream, so that we can stream to the messages. And when you execute this, you'll see that there's a human message. As soon as that is triggered, you get a tool call which fetches the list of tables, right? So the AI is doing this in a loop. It decides that it needs to call the SQL DB list tables. So now it knows all the tables that are available. It decides to make another tool call to fetch the schema or the relevant schemas, as you can see here. And then it makes another tool call to create or generate the query. It calls the query checker to check the query it has generated. And finally, it makes a tool call to execute the query, right? And as you can see, the answer is here, which I think is pretty cool. However, in a typical React agent like that, you don't really have much control, and it's all up to the LLM to decide. But what if you want fine-grained control over the agent flow? That's where LangGraph becomes very useful. Let's look at how to set that up. So what I've done here is essentially got the tool, created a tool node, and I'll explain what this tool node is exactly in a moment. Same thing, I've got the run query tool as well, create another tool node. We've created the list table tool call, so a function to make the tool call. As you can see here, there's tool call that we have described. The tool call message, which is an AI message with content that's empty, but the tool call that's passed in. We get the list table tool from the toolkit that we defined earlier. The tool message, which is then received by invoking the tool that we just fetched. And finally, an AI message which has the list of all the tables. We return that back to the message state. And then we define a call get schema where we pass in the message state again. We create an LLM with the tools that are binder to it. So the get schema tool binder to it essentially. And we invoke that with the state of messages that we currently have. This will trigger the LLM to get the schema for the relevant tables. We define a generate query system prompt, quite similar to the React prompt that we described earlier, with a few adjustments, of course. Right? And then we create a function to generate query. Again, we pass in the message state. We create a system message where the role is system and the content is the generate query system prompt. Again, we bind the tools to the LLM, the run query tool, and then we invoke it to get a response. Right? So this includes the system message plus the current state of messages, which then returns a response. Then we define a check query system prompt, right? Quite similar again, but it's intended to check the query for any flaws or mistakes. We define a check query function. Again, you pass in the state of messages. The system message is defined here. So the role system and the check query system prompt. Right, we get the last tool call, the user message. We bind an LLM with its tools again. So this time it's the run query tool. We get the response from invoking this LLM with tools. And then we store that back into the message state. We also need to add a should continue edge that will be required later, and you'll see it when we start building the graph. Right. Essentially what this says is that if the last message had a tool call, right, then you check query. If it did not have a tool call, then it ends and then provides a result to the user. To build the graph, we're going to start it with the state graph. So this is how you build it in LangGraph. You start with the state graph, and then you start adding nodes. And we're going to add the node for list tables that we created the function earlier, right? Then call get schema. Again, we created this function earlier. This is the tool node that we created earlier, right? And if you remember from my previous video, you got to actually execute the tool call, and basically this tool node executes the tool call. Then you add the generate query function, the check query function, you add the run query node, and after that you start adding all the edges. So from the start it goes to the list table, from the list table to call get schema to get schema to query generate. And then you add the conditional edges where it either generates query or checks for should it continue. If it should continue, then it goes to check query followed by run query, and then from run query back to generate query. And essentially then compile this. If you draw the diagram for this, this is how it's going to look like. You start, you have the list of tables, call get schema, generate query, and check query, right? Run query, and then back to generate query and end. Again, let's see this in action. Who are our top 5 customers by total spend? We're going to stream through the graph to see what's going on in the background. As you can see, this is the human message. It first fetches the list of tables, then invokes a tool call to get the schema of relevant tables, right, as you can see here. Then it creates the query. It checks this query, right, and then it executes this query. And just like that, you have the top 5 customers by total spend. All right, now let's connect the dots. We've seen the logic in isolation, but this is where it gets fun. Wiring everything up so the pieces actually talk to each other. I'll walk you through the code and you'll see how the chat interface, the FastAPI backend, and the LangGraph AI agent all fit together. By the end of this part, you'll have a working understanding of how everything ties together for the Text-to-SQL agent, so you can put your own into action. All right, let's take a look at the code. So I've already set up the backend and frontend for you. The frontend is a React Next.js app, which uses the Assistant UI library for the chat interface. I'm not going to go through all of this code, but what's important is the assistant.tsx. And as you can see, we're making a call to our backend server to get the messages. Next, we set up a backend application in Python, right, which uses UV for dependency management, and it's basically a FastAPI app. As you can see here, I've initialized the FastAPI application. I've added some middleware, so the cross configs. I've added the LangGraph route, where I pass in the app, the SQL agent, and the route that I want to add. And finally, I spin up the server. So what exactly is this LangGraph route? So this LangGraph route does 2 things. One, it adds a route to the FastAPI app. And second, it converts the incoming messages from the UI to LangChain messages, and the LangChain messages back to the UI messages. Now, I'm not going to go through all of this code, but you can find this on the Assistant UI documentation, and I highly recommend you go through it. Then we'll set up the LLM. So we initialize the LLM using the init chat model, same thing that we did in the Jupyter notebook. So I hope this is starting to make sense now. We've added the agent state. So agent state is exactly the same as message state that you've seen earlier. We initialize all the tools that we require. So the get database tool, the get SQL tools, get DB schema, the run query tool, right? And then I've created this prompt manager that fetches the prompt templates when you give it a template name, right? And I've initialized it here. And now we put all of this together in the agent, right? We initialize our LLM. We define a function called list tables. Just like before, we have a tool call where we have a name, the arguments. This time instead of a static ID, it's a random ID, and the type is a tool call. You have the tool call message. You have the list table tools. You invoke that and pass the messages back to the conversation history. Then you also have a function for get schema. Again, takes in the agent state. You invoke an LLM with tools, so the get schema tool. You take the response, pass it back to the conversation history. Then you have the generate query, again takes in the agent state. You create a system message where you then fetch the system prompt from a prompt manager. Invoke this LLM with a tool called run query, right? Take the response, put it back to the message state. We also create a check query function, which again takes the agent state, just like before. So I hope this is starting to all make sense as to how it ties together. We have the system message again, where we use the prompt manager to get the system prompt. We check for a tool call. We get the user message. We invoke the LLM with the tools, take the response, and again, we pass it back to the conversation history. We create a function which is going to act as the conditional edge, right? Which checks the last messages. If the last message contained a tool call, then it goes to check query. If it did not contain a tool call, then it basically ends and gives the user a response. And then we create the get schema node, which actually executes the get DB schema. We have the run query node, which executes the run query tool. And then we start putting all of this together. We initialize the builder, which is a state graph, which keeps track of all the conversation state. You start adding the nodes in sequence. So first step is the list tables, then is the get schema information, execute schema lookup, followed by the generate query, review and fix the query, and then execute the query. And then you define the workflow path on how each step connects to each other. So those are adding the edges. So you go from start to list tables to call get schema, from call get schema to get schema, and from get schema to generate query. At generate query, you add a conditional edge, right, which checks if it should continue or not. If it should continue, then it checks the query, it runs the query, right? And from run query, it goes back to generate query, and finally gives a response to the user. And then we compile this graph by calling builder.compile. And this ties the whole application together. I've started the servers already, so let's see this in action. As you can see, you get an interface exactly like this. So it looks quite similar to ChatGPT. And you can ask questions like, who are our top 5 customers by total spend? So it's listing the tables, it gets the relevant schema, it creates and executes a query, and then you have your answer. You can also ask questions like, which artists generate the most revenue for us? Again, list the tables, it gets a SQL DB schema, it executes the query, and gives you the answer. Just like that, you have a full-fledged working Text-to-SQL AI agent. All right, so now you've seen everything. The front end, the back end, the LangGraph agent, and the database, all talking to each other. We started with a plain English question and ended with a real SQL query that was executed on our database. That's the power of a Text-to-SQL AI agent. And now you've got the full blueprint to build your own. So how do you take this further? The next step is connecting agents like this to real business workflows so they actually drive decisions. If this walkthrough gave you a clear picture of how a Text-to-SQL AI agent works and how to build your own, drop a like on this video. And if you want to keep learning how to build production-ready AI systems. That's exactly what I cover on this channel. So hit subscribe and let's keep building together.